Okay, so what we're looking at is graphing linear inequalities, and the first example is a pretty straightforward example. We want to find out which ordered pair is a solution if 5x minus 2y is less than or equal to 6. We've got 4 choices. Anytime I'm given multiple choices, especially with a set of ordered pairs in a linear equation or a linear inequality, one or all of these choices could be the correct solution. So I have to try them all out. I can't just assume that when I find one that I'm done, because as we know, inequalities can be a whole region of answers. So the first thing I'm going to do is actually write it down. That's my first step. And I've done that. I'm going to plug in for x and y these values. Remember that in my ordered pair, x comes first, then y. And so for 5x minus 2y is less than 6, I'm going to start out by plugging in 0, -3. X is 0, so I'll plug that in. Y is -3, I'll plug that in. Notice I wrote it with parentheses. I always do that. 5 times 0, 0. A -2 times -3 is a +6, and 6 is less than or equal to 6 because it's equal to 6. So I know 0 and -3 is a solution. Okay, so I need to try 5, 5. I'm going to do the same thing to figure out if that's a solution as well. So it's 5 times x minus 2 times y, is that less than or equal to 6? So I'll plug in 5 and 5. X is 5, y is 5. So it's 25 minus 10, which is less than or equal to 6. 25 minus 10 is 15, but 15 is not less than or equal to 6. So I know that that is not a solution. I'll try the same thing with 1 and -2. 5 times x minus 2 times y, less than or equal to 6. And I'll plug in a 1. -2. Now, I really honestly can't work these unless I write it all down. So 5 times 1 is 5. -2 times -2 is +4, +4. And again, 9 is not less than or equal to 6. 9 is larger than 6. So I know that this is not a solution, that's not a solution. I've got to try one more before I'm finished with this problem. And that's going to be 5 times x minus 2 times y, is that less than or equal to 6? And then I'm going to plug in again the 3 and the 3. What I find out is 15 minus 6. And I need to know, is that less than or equal to 6? 15 minus 6 is 9. 9 is still not less than or equal to 6. So that also is not a solution. So I only have one solution. And that's 0 and -3. All others there are not solutions. I want to check out a second example here. Now I want to look at this one, and I want to know how to graph it. And I've already talked about this a little bit, but I want to remind you of the value of that test point. If I graph x is less than or equal to 4, then on the x-axis, I'm going to find 4. 1, 2, 3, 4. So x is 4. In fact, all values here are going to be 4. So start out by putting a line on x equals 4. Remember, anytime it's x equals a number, then that is going to be a vertical line. And if it's y, it's going to be a horizontal line. Now, I've got this ability to use a test point. I love to use test points because they're easy, especially if I can use 0, 0. Because if I check out, is this a solution? If it is a solution, then I'm going to just shade on that side. So I don't even need to plug in a y. There's no y appearing in my inequality, but there is an x, and the x is 0. So is 0 less than or equal to 4? Well, the answer to that is yes, it is. So that means 0, 0 is a part of my solution, and I'll shade that side. So using a test point, it's kind of helpful. And I want to look at this last problem here, problem number 4. Here I'm going to graph y is less than 2/5 x. Okay, now I don't have a y-intercept because it goes through, it's y is less than 2/5 x plus, and there's nothing there. So I know that my y-intercept has got to be 0 since I'm not written. So I know that I need to graph a line with a slope of 2/5, meaning when I run forward 1, 2, 3, 4, 5, I will rise 2. So I've done that. It's a dotted line because it's just less than. Now, again, I can still use a test point to figure this out. Do I shade above or below the line? And I can do that by selecting, I would select this point -1, 0, or even +1, 0. It wouldn't really matter. Let me say that again. I said that backwards. This is 0, -1. And no, it's 1. It's 0, -1, and this is 0, +1. I said that backwards. I apologize the first time. So either this point, 0, -1, or this point, 0, +1. I think I'm going to use the 0, +1 point. If I do that, then 1 goes here, and 0 would go here. Okay, remember, this point is 0, +1. So if my y value is 1 and my x value is 0, 2/5 times 0 is 0. So the question is 1 less than 0? We all know that's not true. So that means that this point, 0, +1, is not a part of the solution set. So I have to shade over here on this side. And that would be the answer I'm looking for. All right, so that's just a couple of quick examples on how to graph linear inequalities.